So yeah, I'm here today to talk about distributed web scraping. It's my first PyCon since 2015 in Montreal. First time I've been selected to actually speak at PyCon, so I'm pretty excited about that. Today I'm going to be talking about distributed web scraping with Python and some lessons I've learned along the way. So yeah, like I said, the goal of this presentation is to motivate you on when and why and how you should use distributed web scrapers and how you can build one if you need to. So I'll give you an introduction to distributed web scraping. I'll set the stage of when you'd actually want to use one, kind of walk through my journey of how I came to actually needing to build one, what it finally looks like, and then a bunch of tips and tricks and management and Python packages and some cool stuff I found that will help you if you want to build a distributed scraper. So quick introduction to myself so you know that I have some validity of what I'm talking about. My name is Josh. I'm a Canadian. I live in Colorado right now. I'm actually moving back to Canada this summer. I've been using Python for about 14 years now, back in 2.5 when I was in university. I did my undergrad West Coast Canada, and I did my master's in the East Coast in Ottawa, where I did machine learning, natural language processing, and artificial intelligence. I use Python all through that. Right now I'm employed with Department of Defense here in the US, where I use data science and data engineering, primarily in the aerospace domain. I've consulted multiple times for professional sports teams and leagues in a data science, data analytics type role, building pipelines, doing data science, doing analysis, providing analysis to decision makers. And of course, I want to give a shout out to Statistics Without Borders, someone I've been volunteering with for the last, actually just this year is my first time, I'm on my first job. They're a great organization if you want to get back to the community and do some data type work. So if you've ever done data science, you've probably seen these 5 stages of the project or program. You need to collect your data, you need to store your data, you need to clean your data, prepare your data. And after 80% of that work is done, you can finally actually build your models and do the work you need to do and analyze it. This is where this talk is focused on. It's the first few steps here in this process. 80% of my work is just in that first stage of collecting data. Most of my responsibilities come from collecting a large amount of data on pipelines that run overnight. I need to ensure that the data is collected and it's up to date so I can provide it to the rest of my team and they can do the actual analysis on it. So that's really where this talk is focused on and where I'm motivated to come from. So what is web scraping? And what is distributed web scraping? We need to talk about that and make sure we're on the same page. Web scraping is the act of extracting data usually from a website. You're taking some information from it, processing it, and storing it. When we move to distributed, we're implying where we're spreading this work over a large number of computers. This typically means we're looking at large amounts of data. Typically, we're requesting around 25,000 pages at one time. That's usually the volume that I work at. So giving a quick brief before I jump into the journey of how I got there, this is generally what I would present to you as a mental model of what a distributed web scraper looks like. You have your main controller consumer, which generates the jobs. It sends it to a bunch of different nodes. They do their work, and they send it back to the consumer, which then stores and does the final processing of the data. So to show you how I got there, I'm going to walk through my journey of web scraping throughout the last decade. To set the stage, like I said, we're looking at 25,000 pages. So the intent is you're in a situation where you want to collect a lot of data source where the layout's going to be the same. It's going to be the same website. You want to do it as quick and efficiently as possible and ensure you have the fidelity of the data. So for example, say you want to make a Goodreads competitor and you need book data. Your intent would be to scrape book data off of Amazon. You're going to be requesting a whole bunch of book information from their individual pages. You're going to be working with the same templates, and you're going to be extracting the same information, page numbers, prices, titles, authors, etc. This is the place where distributed web scrapers would typically you would want to use one. So when I first started, the very first place is what you've probably done if you've ever worked with the tutorial in web scraping in Python. You create a simple script, it requests the resource, and then it stores the results. Python makes that really easy. Python makes that really easy. With the request library or URL lib or URL lib2, you can easily request websites. You can then pass them to something like Beautiful Soup. There's other alternatives like LXML. They make it easy to process that page and store it. You then have to decide how you want to store it, whether you want to store it to a CSV file, a database, a text file, or just output it to the screen. So doing this once, super easy. You can make a script, run it, get your data. That's good. So from here, when I was working with that base case of collecting a whole bunch of books from Amazon, I didn't want to collect one book. I wanted to collect 25,000 books. So I moved it to an iterative approach. I now have two phases in my scraping job. The first phase would be to collect all the pages I would need to scrape from. That could be going through a search or an index, and then I would need to scrape each of those individual pages. This is done the exact same way as a single request, but just looped over and over and over and over and over, repeating until you're completed. However, like I said, once I started working with a volume of 25,000 pages, a number of issues quickly arose. First, this was very slow. For every request, you had to make a network request. There's a lot of idling while you're waiting for your networks to just return the websites. Say, even if it's 1 second a page, times up by 25,000, that's a lot of time. The second issue I was running into was bot detection. Websites would quickly detect me as being a bot. If they see the same script requesting resources over and over and over and over and over really fast, it picks it up as being suspicious. At this stage, I didn't have any tracking tools, so I didn't know if I was requesting websites twice. And same thing, when things failed, which happens a lot when you're working with networks, I'd have to start the script from scratch, and you're basically starting at zero. And of course, as I've been working with this over the last decade, the internet's changed too. Around 2010, 2012, 2014, you had a lot of pages that were static HTML. Nowadays, you're using a lot more dynamic websites built off JavaScript. So if you're using something like requests, you're not going to get that dynamically generated HTML. So then I had to address these issues with my next approach. So in this, I introduced a number of different advanced improvements, or intermediate improvements to help myself. I'd introduce a middle proxy layer in order to help replicate my actions as if a human were making all these requests. It would randomly pick a proxy at random, feed it through that proxy, so every time the website would see the request coming from a different IP. I started adding headers to my requests. The base requests package in Python doesn't add any headers to it. So if a website sees a request come in with no headers of what browser type it's looking at, it often detects it as being a bot. So not just adding a header, but adding random headers. So every time it looked like a different browser was going to the website. So for example, all of us here at the conference going to the PyCon website, we're all probably going to be on the same IP, but it's going to look as if a whole bunch of different browsers are viewing it, because it is a whole bunch of different browsers for everyone's different devices. One thing I found helpful was adding delays between my requests. One, you don't want to hammer a website and DDoS them, but you also want to add random delays, so it's not a consistent amount of time between every request. Dealing with the JavaScript issue, I started moving off of Beautiful Soup and requests and go to Selenium. Selenium's typically used for testing, but it's great for dynamically generating web content and then extracting that HTML. I also added try until succeed methods. Like I said, networks are tricky. They can often fail, and I'm sure you've gone to a website before and it didn't load, but then you refresh it and load it again. Before, in the previous iteration, these would cause the scripts to fail. So I started adding wrappers to my functions that would simply just keep retrying the request until it succeeded. You only try 2 or 3 times because you don't want to loop forever. And then I started adding some basic tracking to my scripts themselves, just so we know what URLs we need to collect from and what we've already succeeded in collecting. Of course, this introduced more issues. This was even slower. Once you're slowing down your requests, you're going to add time. Once you're dealing with dynamically generated JavaScript that has to load, you're going to be even slower. You now have wasted resources. When you have all those proxies sitting there doing nothing, so for example, if you have 5 proxies and you're rotating randomly one every time, 80% of them are doing nothing. And if you're spinning these up on, say, AWS or DigitalOcean, they're sitting there and you're paying for a resource to do nothing. And at this point, my progress tracking and restarting was really weak. There were still issues that popped up again, which really inspired the distributed scraper. This is around the time when I started thinking about distributed scraping. So the intent was to address all these previous issues that we've just discussed. I want to have multiple nodes working on scraping jobs at the same time. I still wanted to retain that 2-phase approach in generating URLs and processing them. And this is what came up to my mental model. We'll break it down a bit more, but like as I first introduced it, you have a controller which generates your list of work. It's going to feed those into a work queue. Each of your scraping nodes can then start working off that queue. They can individually scrape, and then they'll return results back to the results queue, which can then be consumed and saved and stored for how you need in the future. I should add that there's 5 in this picture, but you can have as many nodes as you want. So breaking that down a bit more detailed, you have the first phase, which is your controller. The controller does the same work that I first mentioned in generating your list of URLs. It goes through your search index or an index page and generates your list of URLs and stores them into a work queue. These work queues offer some cool tools, such as ensuring no duplicates. I'll talk about them a little bit more. Once it's done collecting all the results, it actually publishes them to the work queue so that way the nodes can start working. The scraping node is basically a smaller version of the previous iteration of the scraper that we talked about before. It pulls a URL from that work queue and starts scraping with the same techniques we introduced before. It requests a page, parses the page, and returns the results, returning it back to the result queue for the final stage. One cool side effect of introducing all these nodes with these queues is that you can add and destroy queues mid-job. If you need to add more queues because you want to speed it up, you can spin up more nodes. They can start pulling from the queue without any disruptions and start adding to the result queue without disruption. Same thing because of the cool things that queues can give you. If you destroy a node, even if it's mid-job, you won't lose that progress, and you'll be able to re-request that resource. So then once the scraper is actually done, you send it back to the controller, which doesn't have to be in the same place as the first phase, and it stores into result queue. This queue keeps track of where you've progressed and allows you to keep track of your total progress. So right away, this speeds up your scraping much faster. So when I first actually started doing this, I was working at the volume of about 15,000 pages. I know I said 25 earlier, but 5 years ago, around 15,000 pages. That would take me about 26 hours with the second iteration before the distributed scraper. When I went up to a distributed scraper using about 8 or 10 nodes, that would reduce it down to 4 or 5 hours. That's still a lot of time because you're still looking at a lot of resources, but something you can run overnight without any issues. You're now no longer wasting resources, so instead of having proxies sitting there doing nothing, you can actually employ all the proxies to do something to help you with the overall job. With the introduction of queues, we're improving our fidelity of the process. We're ensuring that all the work is being done, and we're getting the results from all the resources. And of course, then you can automate the whole process. If you employ a distributed scraper on a platform such as AWS, Azure, Lino, DigitalOcean, they all have their own APIs, so you can automate almost this entire process. Of course, the disadvantages with distributed scrapers is now there's much higher cost. Again, these platforms are fairly cheap, so you're not talking large dollars, but there is still a cost to actually employ each of these nodes. Redeployability of code has been a bit tricky, but I have a few ideas on that, and I'll talk about that in a minute. And the other one is assumption of trust. So you're assuming that this entire system is a closed system. You assume that all your nodes are only talking with your queues, and you're assuming that no data is being introduced from another source that could either be malicious or just be not useful. So that is generally a distributed scraper in general, but I want to talk about a few other more specific technical things on these different phases. The first is that the introduction of queues made that distributed scraping job really easy to manage. Queues themselves offer a number of awesome or useful dispatch methods, so you can ensure that the resources are being spread out across the different nodes, whether you want fair or round robin. You get ACK methods, so you can guarantee that your resource has been sent to a scraping node, and then you acknowledge and confirm that results have been sent back before deleting anything. So you have that acknowledgement before you, to ensure that you've completed the job. They can also be wrapped, you're also sending messages across them, so typically you're sending them as text. So you can wrap them in JSON and make it easy to send across and use it with any type of platform or language or tool. These message brokers, again, are really agnostic, so you're not stuck to any specific one. I've typically used RabbitMQ or Redis in all my my own work. My day job, I started using Kafka a lot, but again, you're not just stuck on these, so you can use what you're used to, whether it's AWS data streams, Azure Event Hubs, or SQL or NoSQL databases. Python offers a lot of really useful and easy packages for you to actually start working with these queues. Pika and Puka are the ones I've used most. I haven't used Celery in this context, but I've used it for offloading jobs off websites. Super easy to manage your queues. And the one thing I've really found tricky over the last few years was code management. So as you employ your scraping code to each of the nodes, eventually something's going to happen that's going to break it. Either there'll be an exception that you didn't think of. Say, for example, you pulled a birthday off of a website, and they said that person was born on the 13th month, the 45th day in the year 1045. That can easily break your Python code if you don't have any exceptions to it. So, or for example, if the resource doesn't exist, or it throws weird errors, or even commonly if the website just changes, the layout changes, and your code no longer works. You need to manage that code onto the scraping node itself. A couple options I've looked at over the years was containers, which work. I am not a fan of them personally in this context, partly because I'm not super comfortable with them, but also I find on the nodes themselves, for myself, they're often Ubuntu servers. So I have a lot of bash scripts that I have outside of the container context that I also need to manage. One thing I like is a VCS hook. So every time you start up your scraping node, it just pulls the latest version of the code off a repo. I've looked into serverless computing, such as AWS Lambda. But again, a lot of the time in scraping is sitting there waiting for resources. So when you're using that, you end up paying for Lambda when you're not actually using it. And the ugliest method, which I end up using way too often, is manual deployment of images. I'll create a node, FTP into it, update the code, shut down it, create a new image of it, and deploy all the nodes off that new image. It's not ideal, but I end up being lazy and end up going that approach. So I do want to highlight a couple useful Python packages that are useful in scraping, both in the distributed scraper and in non-distributed scraping. Request Beautiful Soup Selenium. They're your go-tos if you've ever done, like I said, if you've ever done a tutorial, you've seen them. So I won't go too much into them. Click is really awesome. Comes in a lot of other packages, so you might already have it installed. It makes it really easy for you to create command line arguments for your scripts. Retry, back off. Retry and back off retry are two different packages that make it easy, that are essentially function wrappers that, that handle the retrying of failed functions. So for example, if you request a website and it gives you a 404 error because it doesn't exist, it would retry it. And you can give a number of parameters, such as the number of retimes you want to try before you give up. You could add back off, so you exponentially slow down your request between every time. So that's a really useful package. Request cache is a really great one for development. Request is the package to request a resource from a website, but request cache actually caches that result. So every time when you're developing and you're testing and you're building a script for the first time, you don't have to re-grab it new every single request. You can just grab it out of your cache, and it'll help speed up your development time. And fake user agent was a really good one that I found recently. I learned about it from one of the Python podcasts. I can't remember which one. But it, so what I mentioned earlier before introducing random headers for your requests, it uses a real-world database, and it gives you a random header that's based on distribution of what they actually see in real life. So instead of just adding a random header, you're adding something that you're likely to see, or the server's likely to see in real time. So just some other considerations, probably for myself, probably to think about, you definitely want to add. Full automation, I haven't fully gotten there yet to fully creating this, partly because I'm lazy and busy just managing these servers, processes and getting my team working. But you can fully automate them, something I want to investigate more into. Alerts are something you definitely need on all of your distributed web scraping scripts, whether it's an SMS or an email. It makes your life so much easier if you can be aware as soon as it happens if there's a failure. So for example, there's a network issue, or you got a 503 error because you got banned, or because the website no longer exists, or the page doesn't exist, or the layout changed. And also for completions and success, you also want to know when it's succeeded, so you can actually go back and continue the next phase of whatever you're working on. And of course, all the previous things I've talked about still need to be addressed. So I kind of went through that a little bit quicker than I hoped, but yeah, so in conclusions, Python itself makes scraping really easy. Large jobs require a lot of work to ensure the fidelity and ensure that you can actually scrape all the resources, especially in a reasonable amount of time. Distributed web scraping is an approach you can use to improve your fidelity and speed up the time to actually request all these resources. However, it does come at the cost of a higher actual resource cost. So thank you for that. I don't believe we're doing Q&A, but I'm here all weekend, so if you ever see me this weekend, just come up and chat. So thank you.